type and wait. Something I might start by noticing is I notice they have 4 and 6 and 10, and this one has 4 and 6 and 10. Interesting. I see 4 and 6 and -2, 4 and 6 and -2. I'm wondering, why does it look like that? All right, when you're ready, when you've typed out what you've noticed, go ahead and press enter, send it to me. Oh yeah, lots of chats. Thank you. Go ahead and keep sending those. Amazing. I'm going to start with a few of them. I say unnoticed letters. Yes, absolutely. There are X's in these top ones, right? They have sets of certain repeating numbers for sure. 4, 6, 10, 4, 6, -2, right? We see 4, 6, 10 here and 4, 6 and -2 there for sure. The first numbers have 4, 6 and 2. There's 3 numbers for each equation for sure. The numbers outside the square root are even. Absolutely, yeah. So 4 and 6 and 10 are all even numbers. 4, 6 and -2 are even numbers. If it has an X in the equation, every number has an X. Ooh, great observation, right? 4X, 6X, 10X, right? Each of them have them. 4X minus 6X equals -2X, all right? There are radicals, has been noticed, definitely there are radicals. Does anyone notice, maybe you can come off mute, how are these related? Oh, well, actually, no. Let's do this. Do we agree, is 4X plus 6X, does it equal 10X? Do we agree with just this top part here? Does 4X plus 6X equal 10X? I've got a few people who think yes. I'm hoping we all agree yes. Yeah, definitely, right? If we have 4 X's, right, we have 4 of them and 6 of them, then we add them. Yes, Emiliano, definitely we add them. 4 plus 6 would be 10, for sure. So in that same world, if we have 4 of these square roots of 3 and 6 of these square roots of 3, then, and we add them together, we're going to get 10 of those things, right? I see one noticing says the outside one adds and subtracts, but not the inside. Absolutely. What an amazing noticing, Moses. We have 4 of these things and 6 of these things. So we end up with 10 of these things, right? 4 of them, 6 of them equals 10 of them. Okay, cool. What about subtraction? Do we agree that 4X minus 6X equals -2X? Is that a true statement? Roxana agrees. Yeah, looking like more of us agree. 4X minus 6X equals -2X. Yeah, so then does it make sense that 4 of these things minus 6 of these things would be equal to -2 of these things? Yeah, absolutely. These are related in the same way. So it's just showing us that our old rules of addition and subtraction are the same. They're not changing, right? Like our old rule of adding is still our new rule of adding. We're just going to be adding radicals today rather than adding x's today. But it is exactly the same rule. If I have 4 of something and I have 6 of that something, then altogether I have 10 of that something. Give me a thumbs up in your reactions. A thumbs up in your reactions if you were feeling good about what we have just talked about. Thank you, Amy. I see you. Thanks, Gabby. Thanks, Marcy, Noemi, Jasmine. Awesome. Fernando, I'm here for it. Miss Yama, here for it. Thanks, Emiliano. Cool. All right. We're going to jump into our notes today, right? So we're going to jump into our notes. I'm going to go ahead and open up my breakout rooms. If you're someone who really likes to learn from the video, right, this is your appropriate time to start doing that now. Thank you, Alan. If you're someone who likes to learn from me, then we are going to do that right now. Make sure that you have a piece of paper, pencil, piece of paper, and a pencil. That is what you need. And then we will jump in here. All right, I'm gonna go ahead and open these rooms. If you like to do team video, go ahead and jump there now. If you are with me, go ahead and answer this poll. How much time do you need to be ready here? How much time do you need? So go ahead and jump there. Hi, Samantha. Want to take that attendance? Glad you could join us. All right. Cool. Let me go ahead and pull this up for you. Sharing screen. All right, looks like most of us are pretty ready to go. We have a few people who just need to take a minute, totally fine. Hi, Unique. Hi, Unique, glad you could join us. Go ahead and take attendance. We're just getting started on notes, so you're free to jump in. All right. If you're taking notes with us, you're gonna go ahead and go to note 24, right, note 24. We're doing adding and subtracting radicals. So that can be the title today. Adding and subtracting. All right. So remember how in our process here, right? In our process, we had 4 x's, 6 x's, and that equaled 10 x's when we added them together. We have 4 square root 3 plus 6 square root 3 plus 10 square root 3. In order to be able to add them like this, they have to have the same radicand. They have to have the same number inside in order to be able to add them together. So if I want to add these together, right, in this example 1, I need to simplify because right now I cannot combine square root of 45 with square root of 5. I need those numbers to be the same numbers on the inside, the same radicand. So what I'm going to go ahead and do is practice my skills from last week where I broke down, I simplified the 45. How can I break down 45? What multiplies to get 45? And Jamie can come off mute either way.
9 and 5.
9 and 5, yes. Yes, 9 and 5, absolutely. Thanks, Unique, as well. 9 and 5, awesome. Can we break down 9?
3 times 3.
3 times 3, absolutely, thank you. Right, 3 times 3. And I go ahead and cross out my 9. Crossing out my 9. All right. I have a group of 3 here. That group is going to come to the outside along with the 2 from before. What number will remain inside?
5.
5, absolutely. Yeah, 5 is going to remain inside. Thank you, Emiliana. Thank you, Gabby. So I have 5 on the inside. So I have 2 times 3, which is 6, square root 5. And I'm going to bring down this whole thing minus, ooh, funky minus 9, minus 2 square root 5. Now that I have simplified, do I have like terms? Are they the same number on the inside? Yeah,
Yes.
absolutely. Yeah, I do. So now I have 6 of these things and I'm taking away 2 of them. So how many would I have left over? 4, yeah, totally. Thank you, chat. I have 4 of them left over, and they are square root 5. So I don't just want to write the number 4, right? I have 4 square root 5 left over. So 6 of those things minus 2 of those things is 4 of those things. 4 of those things. So the first thing that I did, the red part here, first thing that I did was simplify. First thing that I did was simplify. And then the second thing that I did was combining any like terms that I have. I was only allowed to combine them because they were like terms. Hi, Adrian. Thanks for joining us. Go ahead and take attendance. We're just getting started with notes. We just finished the first one. All right. Go ahead and take a moment to write down number 2. We're going to get started on number 2 here in a moment. All right. What is my first step? What was that first step that I needed to do?
Simplify.
Simplify. Thanks, Roxana. I need to simplify. Can I simplify 12? Can I break down 12? Ah,
Yes.
Gabby's already knew what I was going to say. 6 and 2. Roxana, were you going to use 6 and 2, or were you going to use a different number?
Yeah, I was gonna use that number.
Great, you could use 6 and 2. You could also use 3 and 4. All right, so then 6. Roxana, how can I break down 6?
2 and 3.
2 and 3, perfect. 2 and 3. Amazing. So I have the -3 from before. Do I have a pair here? Do I have 2 of a kind?
Yes. Oh, the 2.
Yep, I have the 2s, right? I have the 2s here. For sure. The 2s are going here. And left over 3. Left over 3. Definitely. Awesome. So I have -6 square root 3, because I'm doing -3 times 2 on the outside, and then square root 3. All right. Can I simplify 3 square root 3? Can this be simplified? No. Gabby, how do you know that it can't be simplified?
Because you can't break down 3.
You can't break down 3, right? So can't do anything with 3. So I'm just going to go ahead and pull it straight down here. Plus 3 square root 3. And then how can I break, well, can I break down 20?
Yes.
Break down
4 and 5.
4 and 5. And I saw in the chat that I can also break down 4 into 2 and 2. All right, 2 and 2. So I'm going to bring down here, bring down my +3. Do I have a pair? Do I have a pair from the 20?
The 2s.
The 2s. And I have the 2s. And I have a 5 left over. Right, 5 left over. So I have 6 square root 5. I'm multiplying 3 and 2. 3 and 2. Definitely. Can I leave it just like this? Should I leave it like this?
No,
Why not?
it's a combined like term.
Ooh, yeah. Zephyr, which ones are like terms?
-6 and +3.
Zephyr, tell me one more time. You cut up just a little bit there.
-6 and +3.
-6 square root 3 and +3 square root 3, right? Those are like terms, right? They're like terms because they have the same radicand, right? Same radicand. is it, oh, wait, let's actually see something here. Can I just like plop this pink square root 5 right here? Like this 6 square root 5? Or does there need to be like an addition or subtraction or multiplication, an operation sign here?
Addition.
Addition, yes. It is addition. I'm bringing that addition sign straight down. Right, so that addition sign's coming with me. Okay, so -6, -6 minus, or -6 plus 3, what is that going to make? -3, thanks you need. Right, so -3 square root 3. And then I'm going to bring down this plus 6 square root 5. So this is the first time, right? The first time that we see that these terms are not like terms, right? These are not like terms, so we cannot combine them. So this is actually going to be our whole answer, right? We combined what we could, right? So we did that second step here, combining like terms, right? We combined what we could, but we can't combine any further because they're not like terms. They're not like terms. I want you to put in your own words. We're going to do another type and wait. We're going to do another type and wait. I want you to put in your own words, why are we not allowed to combine these? What tells me that I'm not allowed to combine these? So type your answer. What tells me that I'm not allowed to type these? I'm sorry, not allowed to combine these. Type your answer. Oh, I see a few people pressing enter. Don't press enter yet. Give people some think time. All right, now send to me. Go ahead and send to me. I have one idea that they're not the same numbers. Yep, not the same numbers inside. The second number doesn't match. The inside number doesn't match. It's not the same radical. Love that. They're different numbers. They're not like terms, the 3 and the 5. Yeah, the 3, the radicand, and the 5, the radicand are not the same. Perfect. Amazing. Great job, guys. All right, team. We are going to do one more here. Right, one more. Before we jump in there, go ahead and take a moment to write this down, as well as answer this poll. How are we feeling on this topic so far? How are we feeling on this topic so far? All right. Looking pretty solid. Take another moment, write down number 3 on your paper if you haven't yet. Be careful, there are indexes this time, indices. All right. Something to note, this little baby 4 right here, this index of 4, notice how it's so, like it's small, like an index, like an exponent, right? But it's actually like inside the little arm of the radical sign. That's different from these numbers here, where there is a number in front, right? This is just a multiplying in number. This is a coefficient. This little baby number is telling me groups of how many, groups of how many. So we're leveling up. And yes, absolutely, Jasmine. In this case, we're going to do groups of 4. Groups of 4. All right, let's get started. What can we do with 48? What can we do with 48? I see one vote for 12 and 4. I like it. 12 and 4. If you didn't necessarily know 12 and 4, you could have divided numbers, right? 48 divided by 2. You could have used 24 and 2. All right, how can I break down 12?
6 and 2.
6 and 2, absolutely. How can I break down 6?
3 and 2.
3 and 2. Perfect. Is there anything else to break down?
4.
The 4 and how?
2 and 2.
2 and 2, for sure. Excellent. All right, so we are looking for, as Jasmine told us, we're looking for groups of 4, 4 of a kind, right? 4 of a kind. Do we have 4 of a kind here?
Yes, the 2s.
Yeah, the 2s. Thanks, Roxana. We have the 2s, right? So those 2s are coming to the outside. We still have our 4th root. What's left on the inside?
The 3s.
The
3.
3. Just 1 3, right? That 3 there. All right, so we have 2 4th root of 3. And then I'm going to bring, can I simplify this at all? Can I simplify 3, break it down?
No.
No, there's nothing I can do there, right? So I'm just going to bring this straight down here, minus 2 4th root of 3. Ooh, wow, already getting interesting. All right, and then let's try breaking down 72. 72, how can I break that down?
18
That's a big old number. 18 times 4? Gabby,
Yep.
did you just know 18 times 4 off the top of your head?
Yes.
Wow, I'm impressed. If I didn't know 18 times 4, what else could I try? Any ideas?
36
Okay, so
times
ooh,
2, I think.
36 and 2. Yeah, definitely. I was going to say, sorry, Gabby, I wasn't particularly asking you, but thank you for answering that question for us. I know we got a little stuck, some of us, on our big numbers, right? So if that is you, if you get stuck on big numbers, what I would recommend is just going to a calculator and typing in the big number and just try dividing by 2, right? And so then you see, okay, 2 and 36. You're like, okay, 2 and 36. That would work for me, right? And then you can say, okay, now I have 36. I'm going to try dividing by 2, right? Oh, and that works too. So I have 2 and 18, right? And then, okay, I'm going to try 18. 18 divided by 2. Oh, that works too. So I have 2 and 9, right? And then we probably know 9 is 3 times 3, but if you didn't, you could do 9 divided by 2, and you're like, oh no, that's a decimal. I'm not going to try 2. Let's try 3 this time. So I see, oh yeah, 3 and 3. So I could say this is 3 and 3, like that. 3 and 3. Nice. All right. How many? We're looking for groups of how many on this one?
3.
Groups of how many? Yeah, 3. Absolutely. Jasmine was quick on it, ready to chat me. We're looking for groups of 3. So I have 3 2s. It's going to come to the outside. Is it positive 2 or negative 2 based on my problem here?
Positive?
Positive. Good guess. We have a positive here, right? We're positive, so this is going to be positive 2. And then we have 3, a cube root. What is left inside? 3 and 3, right? We have to put those numbers back together here, right? So 3 times 3, what's 3 times 3?
9.
9 for sure. So the 9 is going to go here. We have to put the 3 and the 3, both of them need to go back in there. So we can't just write 3. We have to write 3 times 3, which is 9. These are our leftovers. 3 times 3. Okay, friends, do we have any like terms here? Can we combine any like terms?
Yes, the 2s. The
4th
2.
root?
Yeah, the 2 first ones.
Yeah, we have this one here, 2 4th root 3, and minus 2 4th root 3. What's going to happen with these?
They're going to disappear.
Yeah, they disappear, right? They become 0, right? We have 2 of them, and we're taking away 2 of them. So then we have 0, right? So this makes 0, basically, right? And then we have plus 3 cube root 9. Do we normally write 0? When we have 0 something, do we normally write 0?
No.
No, we don't normally write it, so we're not going to write it in this case either. Do I need to have this plus sign here, or is it just automatically plus?
It's not necessary.
Yeah, not necessary. So then my answer is just 2 cube root of 9. So we had more steps this time, but the same idea, right? Same idea. We still first, we were simplifying. And second, we were combining like terms. Something to be careful of, we were allowed to combine these ones, the purple ones, because they were fourth roots. We're not allowed to combine this one because it is a third root, right? If we have cube roots, even if this was a 3 in here, we would not be allowed to combine it with this one because they have to have the same index in order to combine them, right? The same index they have to have, right? So we can combine these because they have the same index of 4, but we cannot combine this one because it has an index of 3. Aha, I'm glad that I was able to answer your question. So even if we had like 2 fourth root of 3 plus 6 with cube root of 3, we cannot combine these because these are not like terms. The yellow and the green are not like terms. So something to think about. Not like terms. They're not like terms because they don't have the same index. Cool. All right, after seeing our 3 examples, wow, I never ended that poll, I apologize. I'm gonna relaunch it though. After seeing our 3 examples today, how are you feeling? We are exiting the end of our notes. We did 3 examples. Awesome. All right. Here's where we ended up, my friends. We ended up with many 4s and almost as many 5s, which is great. A few 3s, which is totally fine. We have some time to work. I want to show you what your assignment is going to look like today. Your assignment will look like this. We are already done with the notes portion. You've already got a quarter of the points, which is awesome. You do have 2 options. I know some of us love that iExcel option. I know some of us love working on paper. You can decide which one you want to do. Be careful that you go to the score or the number of problems that you should go to based on what you are at. If you really are up for a challenge, there are a few challenges questions here at the bottom. And then you have your checkpoint form. So that is it. In terms of points, you get 10 points for taking your notes. You get 20 points for this section, whether you do option 1 or option 2. Both are worth the same number of points. And you get 10 points for taking the checkpoint form, right? So that is how your points break down for today. So the schedule for the rest of the day is like this. We're gonna have some work time right now from 9:37 until 9:45. At 9:45 until 10:30, you're working asynchronously, right? You're working asynchronously. And then from 10:30 to 12, you have Spanish. And then you also have office hours available. So these might be flip-flopped. Maybe you go to Spanish straight at 10:30. Maybe you go to office hours. You can come back at 10:30 for office hours, however you would like, right? So this is our schedule for today. You're going to be working asynchronously here in a few moments. And then at 10:30, we will be available again to support you on any questions that come up during this time. Okay. Thanks, Jasmine, for helping Amir in the chat. I see you. Does anyone have any questions about the timing for today? This is optional office hours. You do not have to come back, but they are available. I see you with that X. I like these like little things, emojis. Awesome. Okay, teams, your breakout rooms are still open. So if you want to jump in and chat with, just say hey to your friends. Otherwise, I'm going to let you go ahead and get started. Here is your assignment. I will drop your assignment into the chat so you can get there really quickly. And then you can choose either option 1 or option 2. Option 1 or option 2.